Hello everyone and welcome to a quick review video on factoring that we will be using when we do partial fraction decomposition in the last couple of episodes of season 6. So first I want to remind us the meaning of the word factor. If you have objects that are being multiplied together, then we call one of the objects in that product a factor. So for example, if I had the expression 2x squared, then it would be correct to say that 2 is a factor of that expression. It would be correct to say that x squared is a factor of that expression. And it would also be correct to say that x is a factor of that expression. If you think about 2x squared as 2 times x, then x is a component of this product. Factoring, when we talked about factoring is the action of multiplication in reverse. It's taking something and rewriting it as a product of simpler factors. So for example, if I were to factor the expression x squared plus 5x plus 6, then I would be taking that quantity and I would be rewriting it as a product of simpler factors. In this situation, this polynomial is equivalent to the product of x plus 2 times x plus 3. So I'm rewriting it as a product of these simpler linear factors. Now, if you're given a complicated expression and you are asked to factor it, there are two main techniques that are used. The first main technique is what is called factoring out a greatest common factor, or GCF for short. And this happens if you're dealing with an expression where all of the individual terms in your expression contain a factor in common. For example, if I have 2x cubed plus 6x squared plus 8x, all three of these terms contain a copy of 2 in that product, and all three of these factors contain at least one copy of x. So 2 and x are factors of every single term in this sum, and 2x can be factored out of that sum, leaving behind just 2 x's from this first term, leaving behind a 3 and an x from the second term, and leaving behind a 4 from this final term. Another really common technique for factoring is if you're specifically factoring a quadratic expression that looks like this: x squared on the front plus some number times x plus some other number in the back. When you're factoring an expression that looks like this, your goal is to come up with a pair of numbers. And you want that pair of numbers to add together to give you this number in the middle, b, and those numbers should, when multiplied together, become this number in the back, c. If you can come up with a pair of numbers that satisfies these two properties, then you can factor this expression just by putting that pair of numbers into this template: x plus the first number times x plus the second number. To show you an example of that, suppose I was asked to factor x squared plus 7 times x plus 12. I'm trying to come up with a pair of numbers which, when you add them together, you get 7, and when you multiply them together, you get 12. Now, a pair of numbers that has these properties are 3 and 4. Therefore, this expression factors as x plus 3 times x plus 4. Another example, if I wanted to factor x squared plus 6x plus 5, I'm looking for a pair of numbers which when you add them together you get 6, and when you multiply them together you get 5. So a pair of numbers which satisfies both of these properties is the pair 5 and 1, and so this quadratic would factor as x plus 5 and x plus 1. This idea also works if some of your values are negative. For example, if I am trying to factor x squared minus 4x minus 12, here I am looking for a pair of numbers where when you add the numbers together you get minus 4, and when you multiply the numbers together you get minus 12. So in that case the pair of numbers is negative 6 and 2, which will do that job. So I can factor this expression as x minus 6 times x plus 2. Now, there is a special case when you're dealing with a quadratic expression that looks specifically like this: x squared minus number squared. This is called a difference of squares. In this case, you're welcome to use the shortcut formula that this factors as x minus c times x plus c. So to show you examples of what I mean, if you were asked to factor x squared minus 16, x squared minus 4 squared, then that would be equal to x plus 4 times x minus 4. If you were asked to factor x squared minus 1 squared, that's equivalent to x plus 1 times x minus 1. If you were asked to factor x squared minus 7 squared, that's the same as x plus 7 times x minus 7. So this is a nice shortcut formula if you are factoring something which is a difference of two squares. Finally, some expressions need to be factored using a combination of multiple techniques. For example, here, if I look at 2x to the third power plus 16x squared plus 30x, the first thing that I'll do is I'll check to see if there's a greatest common factor that can be pulled out of this expression. Now I see that all three terms contain a factor of 2, and all three terms contain a factor of x, so I can pull that 2x out and leave behind x squared plus 8x plus 15. But now I can further factor this quadratic that's been left in the parentheses by asking myself, can I think of a pair of numbers whose sum is 8 and whose product is 15? The two numbers that achieve those goals are 3 and 5. So here I get 2x in the front, and then this guy in the back has been split into x plus 3 and x plus 5.